Hello everyone, welcome back to my channel. This is Hitesh Agarwal. Today we're continuing where we left off from the last video. We're going to continue configuring our layer 2 slash layer 3 network today. Basically rundown on everything we're going to do. I'm going to introduce the network again. Introduce you guys to this protocol. We're going to cover DHCP and VRRP. We're going to start doing some IP configurations. And yeah, so let's get straight into that part. So as per last video, we configured VLANs, STP, and Ether channels, in our layer 2 network here. I added another PC to signify VLAN 30. VLAN 40 we're going to use later. We're going to keep VLAN 40 as it is for now because we're going to use that for checkpoint 2. VLAN 50 is parking that we actually did not configure last time, which we may do it this time. Yeah. So yeah, the first protocol I want to cover, or as you can see from my list here, we're going to cover default gateways, DHCPs, and VRRP. To understand default gateway, basically it's a way for a way for a device to get out of its own network. So let's say we have VLAN 10 here, PC in VLAN 10, it wants to get out of its own network, it wants to reach VLAN 30, it wants to reach this PC in VLAN 30, it has to send that packet to its default gateway. In our topology here, I'm going to configure SW1 and SW2 as the default gateways for all VLANs. There's another protocol, DHCP, which stands for Dynamic Host Configuration Protocol. So instead of manually assigning IPs to each PC in an actual network, we would have a DHCP server. And in our case here, we're going to configure SW1 and SW2 as the two DHCP servers. After we have done that, we will also configure VRRP, which stands for Virtual Router Redundancy Protocol. We configure that between SW1 and SW2. So in case there's a switch failure on SW1, so SW2 will start SW2 will start routing all the packets. In case there's a failure in SW2, SW1 will start taking all the packets and sending it out of the network. So let's first configure the DHCP and get into our mobile term session here. As you can see, we have SW1 here. All right. So we're back here in our two switches, SW1 and SW2. We're mainly going to configure these two switches today. First, we need to enable IP routing. So to enable IP routing, we're just going to do IP routing. We're going to do this on both SW1 and SW2. IP routing. And we have enabled IP routing on these two devices. So before we start configuring DHCP, we need to assign the VLANs an IP address because right now in our topology, we are working with a layer 3 switches, right? So we need to do inter-VLAN routing. So to configure that, we need to assign IP addresses to each switch, or each switch that is going to be doing the IP routing. And in our case, it's SW1 and SW2. What I've decided on the IP address scheme is that I'm going to assign the last two addresses from each VLAN to SW1 and SW2. So in case of VLAN 10, if you do int face VLAN 10, I'm going to configure IP address of 192.168. Let me just actually of 192.168.10.254, 255.255.255.0, no shut. And same thing on here, int VLAN 10, wait for the command. Okay, IP address 192.168.10.253. We did 254 here. I'm going to do 253 here. 255.255.255.0. No shut. Exit. So now we have that. So I'm going to do the same thing for VLAN 20, 30, 40, and 50. Actually, you know what? To make that process easier, why don't we make a script? Why don't, because that will be an easier process, right? To instead of just going manually in going manually each time, let's make a script. And this is also a nice way to understand how to script. So we did it for interface VLAN 20, same thing here, IP address 192.168.20.254, 0, no shot, into VLAN 30, IP add 192.168.30.254.255.255.0, and no shot. We can just copy paste this, change that to 40, 40, this is 50, 50. Same thing for SW2, 253, 253, 3, and 3. So we'll configure this one first. Paste that. Yep. As you can see, this is so much easier to do with its scripting. I like to show it both ways. Sometimes if there's a lot of commands, I would just do the script. And 50 is up. Okay. So now we have interview and routing. What we have not done from last video is I think we haven't assigned the right ports to, yeah, so we haven't assigned the right ports. And we also have PO1 here that we haven't configured, which we should. So next thing I want to do is I want to configure the VRRP. But before we do that, I want to configure our port channel 1, which is this interface over here. Now, last video I said I'm going to make this a layer 3 port channel, which I am. And the reason why I'm going to do that is the reason why I want to do that is mainly because for redundancy, for network redundancy, in case, all these two links fail, in case the link to R1 and R2 fail, we have another link to outside the network to go outside the network through SW2. So that just adds another layer of redundancy to it. So for this link, I'm going to configure a separate IP. I'm going to add another IP address here. I'm going to add this IP, sorry. This IP is 192.168.60.1, 60.0, sorry, /30. /30 means that we will only have two addresses in this network. So that's what it's going to be like. Let's do it. Int PO1. Let's check all the commands. Do we have an IP command here? We should. We do. So IP address 192.168.1 or 60.1, 255.255.255.252. Oh, do we not have the command? IP. Oh, okay, we don't have the command. Let me find why we don't have the command. All right, figured out what the issue was. As I said before, all the ports, well, a layer 3 switch by default works on layer 2, so by default, all interfaces also work on layer 2, so we have to enable layer 3 not only on the switch but also on the interface itself. So here I went ahead and did no switch port, which enabled it to be an IP address or a layer 3 port. Then I assigned the IP address, and you will see it is down, and it may stay down for a while, but until we configure the other side as well. So int PO1, no switch port, IP address 192.168.60.2, 255.255.255.252. No shot. Now there could be a couple different things if the ports don't come up, which they should. You do show IP in brief. As you can see, they're administratively down 1011 is also down. So what we should do is we should go into range G10 to 11 and no switch port, no shut. And if you do shut, no shut. In PO1, shut, no shut. Same thing here. Int range gig 10/11, no switch port, shut, no shut. And int PO1, no switch port, shut, no shut. You do show IP interface brief. Let's see if it did come up now. The ports are up and port channel now is down. That means the port channels are up, but not the ports. Yes, the ports are up, not the port channel. All right, I figured out how to solve the problem that we had. The way I solved it actually is I've seen this happen many times before, and it's mainly because of the way the commands are entered. Cisco devices basically don't want to have a difference in the configuration. What they want is to have a straight flow. So what I did back there, I went and I deleted the port channel entirely and I disabled the ports that were in the port channel. And then I went ahead and started the entire port channel or creating the ether channel again. So I did int range, and this time I did no switch port on the ports itself. Then I assigned the channel group, then no shut, and then I went in PO1 and then no shut that as well. And then now we have the both port channels are up and protocol is down. Um, hmm, that's new. 1-0 up. Oh, there we go. The port channel is up. The interface is up. It was just taking sweet time. All right, so now we should assign our IP address. So in PO1, IP add 192.168.60.1, 255.255.255.252. No shut. Same thing for here. Int PO1, IP add 192.168.60.2, 255.255.255.252. No shut. Now, if you want to confirm connectivity um, from between the two addresses, we can do it. Oh, sorry, we can do it so by going and just pinging it. So do ping the other side. So do ping 192.168.60.1 or 60.2, sorry, and let's see if it goes through with the ping. It does not. Do show IP route. It knows of its own network for channel 1. Okay, this is a new issue that I've not seen before. I may have seen this before, but it is a weird way it is not doing what it's supposed to. All right, now it does. Okay. Uh, so there's a flopping going on between 10 and 10 on the same interface on both sides. Um, Yeah, so that might be an issue for the later time. Saint 60.1 and do show IP route. All right, so it knows about this 60.0 network for channel 1. It knows about all the VLANs as well. Yeah, so okay, /32. All right, so now we shouldn't be having that problem. I don't know why it was flapping before. May have caused it to do that somehow, but now it shouldn't do that. All right, so starting off the next topic, we configure our port channel, which was actually not part of this video. Next, we're going to configure VRRP. To configure VRRP, we need to go back to the interface VLAN, so interface VLAN 10. And if we do a question mark here, and we just see all the commands, we'll see that we have a command here known as VRRP. So right here, VRRP interface configuration command. So if we do VRRP and question mark again, you see VRRP group number. We're going to group number this VRRP group number 1. Group number 10, actually. We're going to keep the group number same as the VLAN. So VRRP, and we're going to configure this in IP. VRRP 10 IP 192.168.10.252. Now I'm assigning this an IP from the same network, but just one address below. VRP done. Do we need a subnet mask? No, we don't. IP, and then we also need to give this a priority. 10 priority, and priority levels. We're going to configure this as 100. And we're also going to configure preempt, which means that this is um, the main switch or the main hub. No, shut. I'll have to configure. I'll have to understand what is happening here. Okay, I have to look at what is happening with 10 as a different topic. So VLAN 10, VLAN 20. I'm going to do the same IP address, or sorry, int VLAN 20 IP add. Oh, sorry, VRP IP VRP 10 or 20. Sorry, VRP 20 IP 192.168.20.252. VRP 20 priority 100 and 20 preempt shut int VLAN 30 VRP 30 IP 192.168.30.252. 30. This is not letting me do that. Wow. Priority 100. We have the 30 preempt. Shut int VLAN 40. Sorry, int VLAN 40. VRP 40 IP 192.168.40.252. I'm going to give this a priority of 90 and preempt. Same thing for VLAN 20 or VLAN 50, sorry. 50. VRRP 50 IP 192.168.50.252. Now, okay, and also VRRP 50 preempt. Oh shit. Okay, so now you configure the other side. For this, I might just do a script because it's causing issues. So VLAN 10, VLAN 10 IP, VRRP IP, VLAN 10, VRRP 10 IP 192.168.10.252, VRRP 10 priority 90, VRRP 10 preempt. Same thing for VLAN 20. VLAN 30. VLAN 40, on the other hand, is going to be the priority on this side. So I'm going to change the priority to be higher priority, 100. And same thing for VLAN 50. Here's is going to be the main one. All right, so we're back. We're going to do the IP here and here as well. So let's enter this information in SW2. Oh, okay, so I have some issues. VRRP, VRRP, and P 30, 40. All right, so basically I'm going to configure that again. Okay, so let's see. If you want to confirm what we are masters of, as you can see, so I'm going to do show VRP brief or interface. Let's see interface, but actually no interface, not interface. I'm going to do brief, and you can see VLAN 10 we are master, VLAN 20 we're master, VLAN 30 we're master, VLAN 40 and 50 are backup. The group address that we're using is 252 from each subnet, and the master address right now, the own interface address is 10, 20, 30, and 254, 255, 254. 253 is the address for SW2, so we do show VRP brief. We can also see the priority here, but what we're concerned with here, 253, is its own interface. We get to see this is the master. They're all the backups. You also see the priority, 100, 100, 190. So that's how we configure VRP. I certainly am having some issues with one interface, but I'm going to look at that later. Next, the last topic we need to cover is DHCP. I'm going to do the same process. VLAN 10, 20, and 30 DHCP servers are going to be on SW1, and VLAN 40 and 50 DHCP servers are going to be on SW2. So to configure the DHCP server, we need to also, well, there's two things we need to do. We need to first configure the excluded range. In my case, I want to exclude the last 14 addresses from the range. And then we also need to configure the DHCP pool with all the necessary information. So let's do that. First, we need to exclude the addresses. To exclude addresses, the command on Cisco devices is IP DHCP excluded addresses. I said I want to exclude the last 14, so 192.168. 10.254, sorry, 10.140, 240, sorry, 240 to 192.168.10.254. This is for VLAN 10. I'm going to do the same for VLAN 20 and same for VLAN 30. So we have this. 3 pseudo addresses range for the 3 VLANs. I'm going to configure the DHCP pool now. So IP DHCP pool VLAN 10. I'm going to name it VLAN 10 for VLAN 10. And I'm going to say network, the network that is following. Actually, let's see all the commands. We have all these commands that we can do, but the ones that we are mostly concerned with is network. We're concerned with, we could be concerned with domain name, but right now we don't have a domain name. We can figure that later. We can also have DNS servers, which I'm going to do later. We have a default router, which is basically default gateway. We can configure this as well. We're going to check the lease time, or we could change the lease time if we want to. And that's about it. So we need to add a network. So network 192.168.10.0/24. And we need to give this a default router. In default router, in our case, we're going to use the VRRP IP because it's redundancy. This is what we're looking for. So default router 192.168.10.252. And is anything else that we need to add? Let's see here. Raw DSC options, we don't need to worry about that. We don't need to configure relay because relay is for when the DSP server is on a different network. For us, that is about it for this one. Yeah, so exit. The same thing for the other DHCP for other VLANs. So IP DHCP VLAN 30 or VLAN 20. IP DHCP pool, sorry. Pool VLAN 20. Network 192.168.20.0 and default router 192.168.20.252. Exit. IP DHCP pool VLAN 30. Network. Sorry, I'm blanking out here. 192.168.30.0 255.255.255.0. Default router 192.168.30.252 and exit. So now we configure the DHCP pool here. We need to do the same thing here on this side for VLAN 40 and 50. So IP DHCP first exclude the ranges 192.168.40.240 to 192.168.40 to 254. Same thing for 50. Oops, sorry. That is wrong. I need to do that. All right. Okay, so IP DHCP pool VLAN 40 network 192.168.40.240.0/24 default router 192.168.40.252 exit in IP DHCP pool VLAN 50. Same thing. Network and default router. Exit. So now we have configured the pool on both interfaces, on both switches, sorry. Now for us to receive DHCP addresses, we need to assign the specific ports to their directed VLANs. So on SW1, this port is connected to, let's see, what port is this connected to? Here it says link from PC3 port Ether channel 0, not Ether, ETH0 to SW1's port gig 3/3. So we go to here and we say interface G 3/3. We do switch port access VLAN 30. And if you see any other commands that we need to add, switch port access VLAN, let's see if we can add any other commands. VLAN 30, that's it. That's all we need to do. What we can do is we can do shut and no shut it, just to enforce the command itself. And for switch on SW3, let's see what the port is on SW3 actually. On SW3 is gig 30, gig 30, so enable conf t, interface gig 3/0, switch port access VLAN 10, shut, no shut. If you do show VLAN brief, you can say, you can see the, wow, it's not letting me, this is what I hate about Cisco switches. They don't let me add the commands. All right, so here we can see 10.3.0, same thing if we do here actually. Do show VLAN brief. You can see 30 is engineering, and the last switch or the last interface to the left here is gig 30 on SW4, and conf t int gig 3/0, switch port access VLAN 20, shut, no shut, do show VLAN brief. All right, so see 30 here. All right, we've configured DHCP. We can confirm if we have received an address on this side, and if we terminal, let's see if config, and we did receive an IP address 192.168.10.1 255.252.550. To confirm this, I don't know how much you can see. Ooh, that's, yeah, that's very visible. To confirm if this is seeable, or we can see the lease on the actual DHCP network, let's confirm that. So on SW1, if we do a do show, actually let's say, show DHCP lease, that's our command, show IP DHCP lease, show IP DHCP bindings. So these are all the commands that we can see. You can see database, we can see the server, pool, and bindings. So we are concerned with bindings right now. So bindings, and here we go. We see VLAN 20, 30, 10, 20, 30 here. The hardware address username. We have the MAC addresses of the devices. VLAN 10, let's see what we're dealing with VLAN 10, the IP address or the MAC address. I think should be seeable here, right here, 14E8, and you say 14E8. So we have the DSP server working. Of course, we're not going to see anything here because we do not have anything connected to it. So if you say do show IP DHCP bindings, we won't have anything here because there is no device in VLAN 40 or 50 requesting an IP address. So that covers this part. Actually, let's see if you can ping from VLAN 10 to VLAN 30. So right now this is VLAN 10, 10.1. Let's confirm if this PC got an IP address as well. If you do an if config 30.1, let's try and ping 192.168.10.1. And as you can see, we got a reply from 10.1. And if we try pinging 20.1, here we go. We have replies from both PCs from different VLANs. So that's how we do intra-VLAN routing as well. Now that covered intra-VLAN routing. We did default routers, default gateways. We did DHCP and VRRP. Starting next video, we're gonna start covering routing. All right, so yeah, starting next video, we're gonna start covering more routing stuff. We're gonna start covering our these routers, and most likely also configure this network here. Instead of the different sites, we're gonna just first get internet connectivity between the PCs. Oh, before I forget, we need to do a write, WR, because if we didn't do this, it would not save and I'll have to do its entirely process again. All right. I will look into the interface issue soon. Don't know why this is causing an issue. I might need to re-add it to the channel. But yeah, as far as I'm concerned, it is working properly. All right, that is it for today. Thank you guys for watching, and stick around for the next video. We're gonna start configuring more routing based and more layer 3 protocols. Thank you.